In this video, we will start making our enemy AI. We will firstly go over creating our enemy state and state machine. This will help us code its various AI states, with the states being idle, chase, attack, and pain. Out of these, in this video, we will code the idle and chase state. Just so that we are all on the same page, an idle state is when your enemy is in idle position. That is, it is not doing any active action, but is instead waiting for the player to come in its range so that our enemy can act upon it. One of those actions is chasing the player, which comes under our chase state. That is, our enemy will chase our player until we are in its chase range. Okay, now let's go over a brief discussion of what a state and state machine is. The theory is exactly the same as the previous tutorials, so if you've already watched any one of those videos, I would just recommend you to skip to this timestamp ahead. And for the others, just bear with me for a minute. Stealing from my previous video of what a state machine is, state machine, a mathematical model that defines the behavior of a system to exist in a finite number of states and transition between set states based on a set number of inputs. Let's take an example. Suppose you have a vending machine, a machine that is currently waiting for you to give it some coin. Once you give it some money, it dispenses your item. Upon collection of said item, the machine goes back into waiting for you to give it some coins again. What we have here now is a finite state machine having two states. One, waiting for coin. Second, dispensing items, with arrows to describe the transition between said states. And the reason why we are implementing state machine in the first place is because our enemy will have a lot of states connected by a bunch of if and buts. Trying to code all of these conditions yourself without any strategy or rhythm is a ticket straight to code hell and jankness. Writing the proper states for our enemy managed by our state machine will not only help our code be more robust and modular, but also help in its readability. So, state machine it is. If you are still not convinced by my explanation, I will leave a link in the description below containing more of the reasoning behind as to why I decided to go with state machine. Anyway, moving on, we will firstly code in our state class. This class will actually hold the code required to run any state the player can be in. By state, I mean the walking state, the idle state, the jump state, etc. etc. As we know, Godot has two process functions that run for each frame of your game to update the game's status. One for a physics that run at a constant 60 frames per second, and the other for every other situation which runs for as many frames as possible per second. So naturally, we will be using these two functions in our state class. Thirdly, another function to handle all our inputs from our keyboard and mouse. Next, we will have two other functions called enter and exit, and will run whenever we enter or exit our state respectively. They can have n number of use cases, like running an animation at the start of the state, like when we enter our idle state, we want our idle animation to run, etc. etc. Speaking of entering or exiting a state, to transition between states, we'll have our three body functions return a state as their return value. This return value will be used by our state machine class to transition between other states. How so? In all three of these body functions inside our state machine class, we will run the corresponding body function of our current state and save its return value inside our variable. If this variable is not null, we will change our state to this new one by running our current state's exit function, change our current state to this new one, and then run its enter function. This is a basic pseudo-code of our state and state machine classes. Now let's get into actual coding. First and foremost, here is the basic boiler project, which contains nothing but just our enemy as a node 3D and some sprites and animations baked in. Let us first start by making our basic enemy state class. We will name the class as state, make its exit and enter function, and then the three body functions with state as a return type. Since this is just a base class from which our individual state will inherit their code from, we can just have these functions return null. We will of course add some more stuff here as we go along with the tutorial, but for now this is fine. Next, we will similarly make our state machine base class. Make a starting state variable, that is the initial state that will be loaded for the enemy once the game starts. Variable for its current state. To unload our starting state as our current state, we will make a new function called init function that runs only once and changes our current state to be our starting state. Speaking of changing states, let us now define our change state function. and then the 3 body functions. Let me just fix these typos. And we have our basic state and state machine code done. Now let us see how we can use them. Basic integration would work like this. First, we will add in our state machine node and then our state node. Rename it to idle, representing our idle state, and attach a new script to it that will inherit our base state class. Let's name this child class as idle state. Then we just assign this as our starting state under our state machine. Now to actually load in our state machine during the start of our game and along with Godot's actual 3 process functions, we have to integrate our state machine with our enemy script. So for this, let us first set up our enemy, which is pretty simple. We will first make our enemy a character body 3D, and since it is a character body now, we have to give it a collision box. With this done, let us make our enemy script. We first add in reference to our state machine, our animated sprite 3D, and our animation player. The latter two will be helpful later on. Under our ready function, call our state machine's init function. And similarly so for our 3 body functions. Rename this class as enemy. Since we will be using our enemies, or rather the character body's data members for our code, let us add in the reference to our enemy inside our base state class. One simple generic way I like is to use groups. We add in our enemy node inside of a global group called enemy, and then just get the first node in this group as our reference. With a long tangent of prerequisites aside, we have our state machine all integrated up with our enemy, and this state machine will run our idle state during the start of our game. So now let us finally code this idle state. As soon as we enter our idle state, we would want to run our idle animation. This is where our animation player's reference would be helpful, as we can just use that variable right here. Speaking of reference, we have to refer our idle animation's name here. A good practice is to use variables instead of hard-coded strings. So we will just create a variable called idle anim inside our base state class and just use that variable inside our idle state. One more thing we will do in our idle state is to apply gravity to our enemy, which will be applied inside our physics body function. This is to ensure that our enemy is always on the ground. Now, to test our changes till now, I will just add in our enemy to our test level and adjust its scale accordingly. And with this, the second part of this tutorial is also done. Now let us see how we can implement our chase state. First, let us make a new 3D that will act as our chase state. Then we add an area and a collision shape 3D. This will act as our sight. That is, whenever our player enters this area, we will transition from idle state to the chase state. Speaking of that, I think it is better for it to be under idle state, as it will primarily be used for transition from idle to chase. Then we make a similar area 3D under our chase state. This is the active side of the enemy. That is, our enemy will keep chasing our player until the player is inside this area and transition back to the idle state if it is not. I have kept both of these areas different for a more modular and independent design of our enemy, as you might want to customize this active site later down the line. One more thing, since these areas will only be used to detect our player, we will just set the collision mask's value to our player layer. Make a new script for our chase state and let us start the coding. Make a new class called chase state and leave this script because we have to go and do some prerequisites again. Open your base state class and similar to our animation, add in the reference to both of our chase and idle state here. Now fill the value of both of these new variables independently for both of our idle and chase state nodes. Now open your idle state and let us see how you can transition to chase state from here. As I told earlier, as soon as our player enters the site area, we will transition from idle to chase state. So first, for that, we have to add the reference of our site area 3D here. And under our process physics function, check if this site has any overlapping bodies in it. Since this site only checks for our player, this if condition will only be true whenever the player enters our area 3D. And if the player does, we will transition from idle to chase state by returning the chase state here. We will follow pretty much the same logic for our chase state also. So let me just copy paste it. Add in the reference to our walk animation and refactor our process frame function such that we chase our player if our player is inside our side box, and if not, we return to our idle state. Before we chase our player, we need to know where it currently is at the time of running this code inside the game. For this, we again add in the reference to our player, similarly to our enemy node with the help of global groups. We now add in the movement speed of our enemy. This will be the speed by which our enemy chases our player. First step would be to have our enemy look at our player. Look at is a built-in function provided by Godot. This function rotates our forward vector such that it points towards the position we have provided in the function's argument, effectively making our enemy look at our player, hence the name. And now to move the enemy is a very simple affair by having it move forward with our movement speed. And since we are dealing with velocities here, it is ideal to put this block of code inside our process physics function instead. One more thing we need to make a note of is that when we exit our chase state, we reset our enemy's velocity to 0. If we do not do that, we will carry over our velocity in our idle state as well, which we do not want. One last thing before we end this part is that we don't actually code our chase functions like this. In reality, chasing the player can have multiple phases, like going straight towards the player, or circle shaping around it, or moving with some offset. Let me show you a very basic yet effective style of making such phases. First, we have to define our various phases. For simplicity's sake, let us say that our enemy follows our player with some random direction offset in each of these phases. We first extract our movement direction to be a result of this randomized direction generator function. The actual logic of this generator is not the concern of this tutorial, so I will leave as a creative activity for you. Just do whatever you want here, but just return a vector 3 at the end of it. We will then set up a change direction lock. We will only change our direction, or rather move on to the next phase of our chase state if we are allowed to do so by this lock, and if not, we will continue moving with the current direction that we have. If we are allowed to change our phase, we will firstly lock our can change third variable, map our new direction, and create a timer for set frames that will unlock this variable for us, allowing us to transition to the next phase of our chase. Essentially, this timer's clock is the duration of our current chase phase, and as soon as this timer runs out, we change our movement direction. That is, switch to the next phase of our chase state. With this, we are finally done with this part. I know a lot has been covered today, and naturally this video is very long, so take your time to digest all of this and leave any comments if you want to discuss any of the things that I've taught here further. Next week will mark the end of this tutorial series, wherein we will cover the attack and pain state of our enemy and integrate and close everything together. Hope you guys like this series till now. Don't forget to like and subscribe, and catch you next week. Bye bye.